Yes, good afternoon students. I said yesterday itself the polymers are going to be having, so many are there. Just I will be going to take the list of the polymers, or you are able to see over there on the screen. Just we will discuss one by one what they are going to have and what the uses they are going to have. So that is only we can able to do it from this one, and we are going to give the same sheets for you for the Xerox, and you can able to see that one. And if those you want to read from this one, you can able to write it so that it is going to be one practice for you. Okay, and first we'll see the polythene, the name of the polymer, and what will be the structure of that polythene. It is going to have CH2 N times. That is going to be addition polymer, and the monomer is going to be ethylene molecule, isn't it? And we are going to use it as an insulator, anti-corrosive, packing material, household laboratory waste. I think everyone will be by hearting this one, no other option for us. The next one we are going to have polystyrene. It is going to have CH double bond CH2. It is also one of the addition polymer, and there we are going to have, if you can see that particular CH double bond CH2, that carbocation, the benzyl carbocation is going to be formed. That is going to be more stable, so that one more we are going to get added to that particular carbon. And we are going to have, it's acting as an insulator, wrapping material, manufacture of toys and household articles. Then we are going to have polyvinyl chloride, PVC, and it is going to be having vinyl chloride is a monomer. And if you can see here, the carbocation is going to be forming. Then we are going to have the polymerization. You can able to see there in the structure, and it is going to be used in manufacture of raincoats, handbags, vinyl flooring, and leather cloths. The next one we are going to have is Polytetrafluoroethylene, which is also called as PTFE, or which is going to be called as Teflon. So this particular Teflon or PTFE is going to be monomeric unit tetrafluoroethene, which is going to have CF2 double bond CF2. That is also going to be addition polymer, which is going to be used as lubricant and insulator and making cookware. I think everyone knows about this Teflon coated plates we are going to have. That is going to be non-stick pans where we are having a Teflon coating. And the next one we are having is polymethyl methacrylate. Polymethyl methacrylate we are going to call as a PMMA or plexiglass. You can able to see the structure. Acrylic acid is nothing but CH2 double bond CHCOOH. Now it is going to be acrylate, is going to be ester methyl acrylate. That's why you are going to have CH2 double bond C, COOCH3 is nothing but methyl acrylic acid, and it is going to be methyl acrylic acid. That's why you are going to show one CH3 group over there, and it is also comes under addition polymer, and it is going to be substitute of glass and making decorative materials. Decorative materials can be obtained by using this one, and it is going to be useful for the nuclear reactors. That glass what you are going to have window, that is going to be made by your polymethyl methacrylate only. Polyacrylonitrile, which is nothing but Orla we are going to call, or it is also called as polyvinyl cyanide, we can able to call it as. And then we are also having addition polymerization. It is also comes under addition polymer, and it is going to be making a synthetic fibers and synthetic wool, we can able to call this one. These are all the names we are supposed to by heart. Which of the following is a synthetic wool? It's going to be Orlan or polyacrylonitrile, we can able to call PAN. And next one we are going to have styrene butadiene rubber, or we are able to call this one as ZRA. We are going to call this one as GRA or SBR or Buna S, we are going to call. So styrene butadiene rubber SBR, it is a short form. Buna N or Buna S. Buna S is going to indicate butadiene, and we are going to have the styrene, that is why we are calling it as 1-butadiene, 1,3-butadiene, and the styrene. These two are going to be the monomers. It's a copolymer, and again it's a addition polymer. That's what you can able to see here, and it is going to be useful for the tires and footwear. And the next one we are going to have called nitrile rubber, which is going to be called as Buna N, GRN, and it is going to be useful for making the oil seals and the manufacture of hose pipes and tank lining. And there we are going to have acrylonitrile and we are going to have 1,3-butadiene. These two get addition polymerized and we are going to get that particular polymer that is called BUNA-N or GRN. And next, if you are taking, it's neoprene. I already discussed this one. It's a artificial rubber. It's a monomer is going to be 2-chloro-1,3-butadiene. See that structure they given is wrong monomeric unit. That Cl bond should be attached to carbon. That carbon should be having the Cl bond and that is going to be attached to CH. It's wrong. That monomeric unit you can observe that Cl should be attached to first carbon, that is CH2 double bond CCl. In polymeric structure they given correctly only. It is going to be acting as insulator. It is going to be acting as insulator and then it is going to be used as a conveyor belt and printing. That is also one more application we are having for this one. And printing rollers also we are going to use. The roller is nothing but what we are using it for making the paper to be rotated. That is called paper roller, printing roller. Next one, polyethyl acrylate. Earlier we have seen polymethyl methacrylate. Now it is going to be ethyl acrylate. It is also addition polymer. It is going to be useful for films and hose pipes and finishing fabrics. And till now whatever we discussed, they all comes under addition polymer. That addition polymers are going to be the polymers which are not going to lose anything. They are directly added up and they are going to form a polymer that is called as addition polymer. And the next one we are going to have terylene. It is also called as dacron or it is also called as PET, PET. What do you mean by PET? Polyethylene terephthalic. So we are going to have polyethylene terephthalate. We are going to be the terylene or dacron. PET bottles we are going to have, no, that bottles are nothing but this one only. Here we are going to have terephthalic acid. The benzene 2COOH on para position, it is terephthalic acid. Ortho position, it's phthalic acid. If it is meta position, isophthalic acid. And one more is called as ethylene glycol. Ethylene glycol and terephthalic acid are going to be the monomers and it's a copolymer and it is a condensation polymer and it's a polyester. All the three. It's a polyester, it is going to be a condensation polymer and it is going to be a copolymer. That is what the things we are supposed to remember about this dacron or terylene, and it is going to be useful for making the fibers, safety belts, tire cords, tents, etc. And next we are having Glyptol. Just now I said COOH on ortho position is called as phthalic acid. Earlier it is terephthalic acid and ethylene glycol. Now it is going to be ethylene glycol and phthalic acid. Now it is going to be called as Glyptol. So it is going to be Glyptol, that is glycol plus phthalic acid. It is going to be useful as a binding material in the preparation of mixed plastics and paints. And next what we are having is polyamide. It's going to be polyamide, nylon 6 or we can also call it as Perlon L. It is going to be formed from the monomer called caprolactam. What is caprolactam? The cyclic esters are called as lactams. This lactam is going to be formed from aminocaproic acid. Already I have shown the structure in nylon 2, nylon 6, aminocaproic acid. That aminocaproic acid is going to be present in a cyclic form that is called as caprolactam. Cyclic imide is going to be called as lactam. So this caprolactam is going to be acting as a monomer and which upon polymerization we are going to get, it is called nylon 6. Always in nylons the numbers what we are going to indicate, they are nothing but how many number of carbons are there in its monomeric unit. In nylon 6 I am going to have only one monomer that is going to be having the compound with 6 carbons. That's why it is going to be called as nylon 6 or Perlon L. It is also useful for making the fibers, plastics, tire cords and ropes. Understand? So these are all comes under polyamides, the nylon 6. The next one I am going to have is nylon 6,6. Nylon 6,6 is going to be indicating it's going to be having two monomers. One is adipic acid with 6 carbon, another one is 1,6-hexadiamine. 1,6-hexadiamine, which is going to have 6 carbons. So total 6 carbons in case of one monomer, another 6 carbon monomer are going to be combined by an amide linkage, and which is going to form a monopolymer called nylon 6,6. It is going to be called as nylon 6,6. So that is what we are going to have, polyamide. It comes under copolymer, and it is going to be a polyamide linkage, and it is going to be useful for brushes, synthetic fibers, parachutes, ropes and carpets. And the next one we are having is Bacalite. It is comes under what you can say the poly linkage only, cross linking polymer. We given the example, it's a cross linking polymer. When we are going to take phenol and HCHO, they are undergoing electrophilic substitution, and they are going to be forming hydroxymethylphenol. Hydroxymethylphenol. It is going to be combined with one more hydroxymethylphenol. Then they are going to form linear polymer, that is called novolac. We are going to get linear polymer novolac. If we are going to get dihydroxymethylphenol or trihydroxymethylphenols, when they are undergoing, they will be getting cross-linked polymer. Actually, what structure here they given only half. You can go through your NCERT textbook. There you can able to find out the cross-linking polymer, how it is going to be. Linear polymer, how it is going to be. Here, what they given is a linear polymer, that is going to be novolac. We can able to get extensive cross-linking polymer, that is called Bacalite. That is going to be useful for making the gears, protective coatings and electrical circuits. Next we are having urea formaldehyde resin. It is also a polyamide. There we are going to have urea NH2CO NH2 and the formaldehyde is HCHO. Then there also will undergo polyamide linkage, and it's a condensation polymer, so that we are going to get a polymer called urea formaldehyde resin, and it is going to be useful for unbreakable cups and laminated sheets. I think everyone knows about this. And the next one, when you are going to take melamine formaldehyde resin, so many times they are going to ask the name of the melamine, IUPAC. What is the IUPAC name of melamine? It is going to be 2,4,6-triamino triazine. What it is? 2,4,6-triamino triazine will be the name of the melamine IUPAC, and HCHO is the formaldehyde. So these two are going to be undergoing polymerization, and they are going to be called melamine formaldehyde resin, which is crockery. Nowadays all crockeries are going to be made by using this particular melamine only. And next one we are going to have polyhydroxybutyrate co-beta hydroxyvalerate. I already explained this one yesterday. That is going to be having 3-hydroxybutanoic acid, 3-hydroxypentanoic acid. When they will be undergoing esterification, that is condensation by losing of water, alcohol and the acid, we are going to get the polymer called PHBV, which is a biodegradable polymer, which is going to be useful for packing orthopedic devices for making the capsules. This is what we discussed yesterday. Artificial silk and rayon. It is nothing but cellulose acetate. They given cellulose only, but actually it is a cellulose acetate we are going to have. That cellulose acetate is nothing but getting the semi-synthetic polymer formed from cellulose and acetate, that already we discussed. And in this cellulose structure, what you are having, the same thing, but extra acetate groups are going to be present. We are going to have different rayons. They are given, that is pyroxylene, viscose rayon, acetate rayon, cupramonium rayon, by which we are going to modify that cellulose, that is going to be giving different artificial silks. That's what you can able to see here. This is going to be used in packages and wrapping industries and photofilms. And the next one we are going to have is silicone polymers. I think you might have read this one in your carbon family. You are going to read this one. When we are going to have trialkyl silane or dialkyl silanes, they are undergoing the linkages Trialkyl silane is going to be useful for termination. Dialkyl silane is going to be useful for extension. That is what we are able to have two OH groups on that one, and that is going to be useful for extending the chain, and they are called as silicones, and they are going to be highly stable for the heat. That is why all your nipples for your bottles, for the feeding, milk feeding bottles, they are going to be used by silicone only. They are highly stable, available in liquid, solid or gas phase. That's why they can be used as even rubber. That's what we are going to use the nipples for the baby feeding bottles. And it is used for surface coating, and we are going to use it for elastomer in case of aeroplanes and missiles. Next one we are going to have is Polyvinylpyrrolidine. It's a blood plasma. So if you can see the structure, N-vinyl pyrrolidine, that is going to be pyrrolic structure. There we are going to have the CO and H bond, and where we are going to have vinyl, that is going to be N-vinyl pyrrolidine is going to be making the structure to be get polymerized, and that polymer which is formed is going to be making the life-saving blood plasma. It is an additive to many basic dye compositions which are going to deepen the color. So that is what we are going to have, the polyvinylpyrrolidine. Polyvinylpyrrolidine is going to be present as a polymeric structure, and which is going to be making the polymer replacing the plasma. So this is the polymers we are going to have in our regular study, and other than this one we are going to have polypropylene, which they are not given here. So the polypropylene is also going to be present. That polypropylene is going to be made by the propene. That propene is going to be get addition polymerization. We are going to get polypropene. And Teflon, we are going to have CF2 double bond CF2. That is also the given tetrafluoroethylene. And these are the polymers structures we are going to have. And you people are supposed to be remember like what type of polymer that one. That is whether it is a addition polymer, whether it is a condensation polymer. That is the question they are going to ask. And you are supposed to remember it like whether it is a copolymer or a homopolymer. If you are going to have more than one monomer, obviously it is going to be copolymer. If you are having only one monomer is going to be repeating, that is going to be comes under homopolymer. Those two we are going to have. And other than this, we are going to have the questions like what will be the monomeric structures for a particular polymer. Say for example nylon 6,6. What will be the monomeric structures for that one? What will be that one? It is going to be adipic acid and hexamethylene diamine. 1,6-hexamethylene diamine. It is going to be one more monomer. And they can able to ask like what will be the monomeric structures which are present in Buna S or Buna N. If you are taking Buna S, it is going to be 1,3-butadiene and styrene. If it is Buna N, it is going to be 1,3-butadiene, and we are going to have acrylonitrile. And what is the common name for polyacrylonitrile? We are going to call that one as Orlan. Or which of the following is going to be called as plexiglass? That is going to be polymethyl methacrylate. This is the way we can able to get the questions from these polymers. And most of the polymers when we are going to take, they are going to be biodegradable, non-biodegradable. What is biodegradable? What is non-biodegradable? That is also one of the chance we are going to have. Biodegradable polymers are going to be all natural polymers, and we are going to have PHBV, and we are going to have nylon to nylon 6. What is the use of PHBV, which is going to be useful for capsule preparation? And what is the use of nylon to nylon 6? It is going to be used for stitching. So whenever you are having the wounds or something, that is going to be get stitched by nylon to nylon 6. This is also one of the one we are having. And what is the use of your Bacalite? The Bacalite is going to be useful for making the rigid substances what we are going to have. So every one is going to be one question. So in this particular area, we are supposed to by heart the things, no other option for us other than by hearting these examples. Frankly speaking, so many uses I am also not able to memorize, but we can't able to do anything. Most of the times they are going to ask either what is the monomeric structure or what will be the polymeric structure and what will be its use. That is the last preference we are going to have. So that's why how many uses you can able to remember them. Say for example, plasma is going to be replaced by polyvinylpyrrolidine. It's going to be a huge memory you can able to get by because It's a famous example. And we are going to make the Teflon or styrene. Those are all the things are going to have certain usages. We will know it in our regular life. But certain things we are supposed to remember them. No other option for us. So try to by heart this one. And anyway, we are going to give Xerox sheet for this one. Still we'll have more clarity for then that is going to be good advantage for every student to have a look into that one. Okay, so this is about your polymers we are going to have, and mostly when we are going to see the polymers, I said the molecular weight determination also. The molecular weight is going to be sigma Ni Mi by sigma Ni, that is the number average molecular weight, and the weight average molecular weight is sigma Ni Mi square by sigma Ni square. That is going to be one more. And this are we are going to have the polymeric structures when we are going to see that molecular weight is determined by average molecular weight methods, that is either number average molecular weight or weight average molecular weight, Mn bar, Mw bar. So Mn bar is going to be giving you by osmotic pressure method, Mw bar is going to be given by your sedimentation method or centrifugation method. By knowing these two molecular weights for a given polymeric chain, we can able to see the polymer is going to be having a dispersion index is how much, whether it is going to have many dispersion or less dispersion. That is equal to 1 for all naturally occurring polymers. It is greater than 1 for maximum we are going to see the synthetic polymers. That is what we can able to get based on dispersion index. Then we discussed about the natural polymers, that is natural rubber we discussed. There we can able to have less tensile strength, less heat resistance, and we are going to have more solubility, and all these things are making the physical properties of natural rubber are lesser, but for the requirements what you are having, in order to improve these physical properties, we are going to have the process called vulcanization. In that vulcanization, we are going to make the sulfur addition to your natural rubber. So that sulfur addition is going to make the rubber to get more tensile strength, more resistance for the heat, and less solubility, less attacking by your oxidizing agents. All these things are making the rubber to be more tensile strength. So that more tensile strength rubber is going to be having 1 to 3% is going to be used for rubber bands. If you are having 5% to 7%, you are going it for tire cords. And if you are having 25 to 30% is called ebonite, which is used for battery cases. These are all the things we discussed. And classifications what I given, you people supposed to be remember. And this is about your polymers, and if any doubts are there when you are coming here, we can able to discuss them, and if anything is there, let us know. By the interactive session might be not possible, just we can go through. Direct interaction is going to be possible on 7th onwards, just we can have on that time. Okay, so thank you everyone, the students, and go through that table if you can. Otherwise when you are coming here, we are going to provide that Xerox sheets, so that you can able to go through this one. The remaining parts what we given, they are not going to be get any Xerox copy. For the one what I displayed here, the table, for that table only you are going to get one Xerox sheet. So that Xerox sheet able to give you the information regarding that particular polymer, how it is going to be useful and all. So that the thing we can able to, and solve the numerical if you can have one MW bar, Mn bar. So like that we can able to practice, and we can able to discuss about the PDI of that particular polymer what they given. Understand? Okay. So just I am concluding this polymers now, and the next what we are going to have the class, we will be discussing the next chapter.